Hello guys, welcome back to our YouTube channel. My name is 𝗍𝗲 and in today's video we are going to solve problems from Codechef Starters 204. So without wasting any time, let us get started. Okay, let us start with our first problem. So the problem name is triangles. So let us see the problem statement. It is well known fact in mathematics that the sum of three angles in a triangle is 180 degrees. We all know that, right? A triangle is made up of three angles and sum of all the three angles is nothing but 180 degrees. So you had a triangle, but unfortunately you only remember the first and the second angle of it, but you don't know the third one. So a triangle, you know the first angle, you know the second angle, but you don't know the third angle, right? So all you have to do is to simply find the third angle, and you have to simply print that. Okay, all the integers are measured in degrees. Okay, so we all know that a triangle is made up of 180 degrees, right? So 180 degrees. So the first one, you know, two angles, right? Which is first angle is 60 and second angle is 60. So can I say my answer for the third angle is nothing but the triangle angles minus first angle plus second angle. So this will give you how much? 60. So the first answer is going to be 60, right? Now let us see the second test case. So we all know that triangle is 180 degrees. First angle is 1 plus 1. So in total 180 minus 2 is nothing but 178. So this is the second test case output. So the problem statement is pretty much simple and straightforward. So let us jump into the code. So the code is also pretty much simple. If you see the input format, you will be given two values. Let us call it as A and B, and let us take the input of C in A and B. And we know that our answer is going to be 180 minus A plus B. And we are going to simply print this. Okay. So let us put the whole thing in an expression and submit. Yeah guys, it is working, and let us go to the next problem now. Okay, so let us jump into the next problem. So the problem name is episodes. Okay, so Chef has started a new series on Netflix, and this series has total n episodes, and each episode is having k minutes long. Okay, let us assume that he started Naruto, and each episode in Naruto will have around 20 minutes, right? So Chef wonders what is the total time it will take for him to watch this series from start to finish. Okay, assume that Chef does not need any breaks in the middle. Okay, so you need to find the answer in terms of hours and minutes. For example, 120 minutes should be 2 hours and 20 minutes, right? So basically, you will be given two values. The first one is n, which is nothing but the number of episodes, and k is nothing but each episode in minutes. Okay. So for example, if there are three episodes, then each episode is going to have 15 minutes. So in total, how many minutes do we have? In total, we have 45 minutes. In total, he is watching 45 minutes of screen time. Okay, the movie, the series. Now the chef wants us to represent these minutes in the format of hours followed by minutes. But if you see, we have only 45 minutes. In order to have at least 1 hour, you need at least 60 minutes. So here we have only 45 minutes. So it is impossible to have at least 1 hour, right? So in this case, the hours is going to be 0 and minutes is going to be 45. So that is the answer for the first test case. Now let us see the second one. 4 episodes and 15 minutes. You are adding plus 15 to this 45 minutes, which is going to have 60 minutes. So can you convert this 60 minutes into this hour comma minute format? Yes. 60 minutes can be represented as 1 hour, and since there are no remaining minutes, you are going to simply put it as 0. Is that the answer for the second test case? Yes. Now next one is 5 and 27. 5 and 27 is going to give you 135 minutes. 135 minutes. So 135 minutes means you can have 2 hours, which is of 120 minutes. And if you subtract 120 minutes from 135, you will get something like 15 minutes more, right? So 215 is the answer for the second test case, right? And the next one is 5 and 59. You can do the math for this, so you will get something like 290 something. It is going to be have 4 hours and some minutes. Okay, just do the math, you will get it. Okay, so for the fourth test case, the answer is 4 and 55. So this is the problem statement. So You need to simply find the total number of minutes, and you need to simply represent that in the format of hours, comma minutes. Okay. So do we need to? Is there any logic for this? No, right? There is a simple maths here. So for example, this is the not this. Let us take this 60 minutes. So let us take the 60 minutes. We know that in 1 hour, how many minutes are we going to have? In 1 hour, we are going to have only 60 minutes, right? So here the total number of minutes that the user is watching is 60 minutes. So if I do 60 by 60, what is 60? 1 hour. So what do you get? The number of hours that the user is watching. So in this case, he will get 1. But what about the remaining minutes? So here you will simply do the number of minutes he is watching modulo 60. Here what do you get? 0. So he is watching. Okay, this one is this one, right? Okay, I'm confusing. Yeah, 1 and 0. This is how we can get the answer. If you simply do division by number of hours, you will get the number of hours the user is watching. And if you do modulo by 60, you will get the number of minutes that the user is watching. For example, let us take the second test case, 135 minutes. So 135 divided by 1 hour, which is nothing but 60. What do you get? 2, right? And 135 modulo 60, what do you get? The remaining one, which is 15, right? So this is how you can get the output in the format of hours and minutes. I think most of you have already got this. So let us simply code it up. Okay, so let us see the input format. You will be given number of test cases, and for each test case you will be given n comma k, right? So let us take the number of test cases first, and okay, then n comma k. Let me take the input, and here it is going to be simple. N by, sorry, first we need to find the total number of minutes. So int total is nothing but n into k, and here we can simply do total by 60, and after this total modulo 60 and line. This should work. Yeah, it got submitted. Let us jump to the next question. Okay, so the next problem is drawing chances. So basically, there is a tournament which are being played by Alice and Bob. So basically, there consist n matches. Okay, so if there consist of n matches, they from this n matches they have already completed m matches. So out of n matches, m matches were already completed, and you also have the results of this m matches in the format of binary string. Okay, in the format of binary string. So if the binary string at the ith character is 1, then that means Alice has won. Alice has won the game. And if binary string at ith index is 0, then Bob has won the game at the ith match. Okay, this is basically what the binary string means. So at the end, whoever has won more matches wins the tournament, right? However, if both of them win equal number of matches, the tournament ends in a tie. Okay, so given the matches that has been already played, is it still possible that the tournament to end in a tie? You need to figure that out. Okay, so basically, let us take the example. So let us take the first test case. So the first test case is 2 2, and the binary string is 1 0. The binary string is 1 and 0. So what is this first 2? This is nothing but the length of the total number of matches. Okay, and this second one is nothing but m. What is m? The number of matches that has been played so far out of n matches. So if you see, out of 2 matches we have already played 2 matches, right? So what is the result? Alice has won 1 game, Bob has won 1 game. So since the number of matches are already completed, so they are in a tie. Yes or no? Alice won matches is equal to Bob won matches. So in this case, the answer is a yes. Okay. Now let us see the second test case. Second test case, the number of matches are 4, and the number of matches result that we have is 3. and the binary string is 111. Okay, now let us see. So who won the game? Who won the game? Alice has won 3 games so far. Uh, Based on the results that we have, Alice has won 3 games so far. What about Bob? Bob has won 0 games so far. So how many matches are we going to play after this? We have played 3 matches. So if you take the difference of n minus m, you will get the remaining matches. So in this case, the remaining matches is going to be 1. So you have one more match that is going to happen. So using this one match, can you make the Alice and Bob tournament as a tie? No, right? So if you see here, in this one match, if Alice has won the game, then Alice score will increase to 4. If Bob has won the game, then Bob's score will increase by 1. No way, if you have tried any possibility, there is no chance of making this game as a tie, right? So in the second test case, the answer is always going to be a no. Okay. Now let us see the third test case. Third test case is going to be the number of matches. The number of matches are 3. The number of matches played so far is 2, and the binary string is 10. In this case also, Alice has won 1 game and Bob has won 1 game. There is one more game which needs to be played. So in this one game, if Alice has won 1 game, then his score will become 2, and if Bob has won 1 game, his score will become 2, right? So if Alice has won the game, then A will become 2, then Bob's score will become 1. If Bob has won that 1 game, then Bob's score will become 2, Alice score will become 1. So there is no way that this tournament is going to end in a tie situation, right? So again here also the answer is going to be a no. Now let us see the next test case, which is 6 and 5. Again, you can clearly see Alice has won only 1 game, Bob has won 4 games. Alice has won 1 game, Bob has won 4 games, and how many matches are remaining? There is only one match remaining. Using this one match, we can't make this equal. Definitely, right? That is expected. Now let us see the fourth test case. Okay, so there are total 6 matches, and the total number of matches that has been played so far is 4. So binary string is going to be 001. So how many matches did Alice has won the game? Only 1 game. How many matches did Bob has won the game? 3 games, right? So can we make them equal? So first of all, how many remaining matches are there? There are only 2 remaining matches. 6 minus 4 will give you 2. So in those 2 games, you can make Alice win the game and again Alice win the game. Now if you do this, then Alice wins is equal to Bob's win, and hence at the end of the game, there is a tie. So this is the problem statement, guys. Now can we think of any approach? Can we think of any observations? So first things first, first observation is that you need to understand is, let's assume that we have a binary string something like this 000, and we have only 1. Okay, the number of n value is somewhere like mm, n value is 6, and m value is, how many matches we have played so far? 5 games. So these are the 5 games result. So how many matches did Alice has won the game? Only 1 game. How many matches did Bob has won the game? In 4 games. Now how many matches are we able to conduct after this game? You can only play one more game. There is only one more game, because 6 minus 5 is nothing but remaining games are only 1. If the remaining games are 1, so if you see, what is the difference? To make Alice wins and Bob's win as equal, how many games you need to have at least? How many games you need to have at least? The difference is 1 minus 4 is 3. I mean, I am taking the absolute value. So you need to have at least 3 games to be played so that you can make Alice and Bob as equal. So that Alice and Bob can win in a tie, right? But if you see, the number of games remaining are only 1. So 1 is less than 3. You have one more game, but you need at least 3 games to make a tie, but you don't have that. So in this case, the answer is always going to be a no, right? In this case, the answer is always going to be a no. Okay. Okay, now let's assume, let me let me change the n value from 5 to somewhere like 10. If I do it as 10, how many matches can I play more? How many matches can I play more? Not 10. Let us take it as 11. So what is 11 minus 6? So the remaining matches are 5. So in these remaining 5 matches, can you make Alice and Bob score as equal? Yes, you can. I mean, you can use one match to make Alice score to increase 1. You can use one match to increase Alice score to increase by 1. Again, one match to increase Alice score by 1. Now you have, what do you have? You have two remaining matches. So in these two remaining matches, you can simply make Alice win the game, and again in the next game you can make Bob win the game, such that both of them will end in a tie. But will this always works? Will this always works? Now let us take an example. Now let us see here. Now instead of m value, let me erase this. Now instead of taking m value as 11, let us take m value as 10. Okay, if you take m value as 10, what will happen? Let us see. So how many remaining matches are there? There are 4 matches, right? So in these 4 matches, you can make them equal. That is for sure. Okay, so this one will become 2. Here the number of matches will be reduced by 1. Again, this one will become 3. The number of matches reduced by 1. 2. The number of matches. Sorry, I am doing it opposite. 4. The number of matches will be reduced by 1. Okay, now you can able to make Alice score is equal to Bob score. That is fine. But you have one more match, right? You have one more match. Who are you going to make this match win? Like, is Alice going to win this last match, or Bob is going to win the last match? If Alice is going to win the last match, then his score will become 5. 5 and 4 is not equal. Then there is no tie. And if you make Bob win, then 5 and 4, then also there is no tie. So this is the second observation. So are you able to understand? So first one is if the remaining matches are less than required matches, then the answer is always going to be a no. What is the next one? So how many matches do we need to make Alice and Bob as equal? How many matches do we need? Let us take this as absolute of a minus b. This will give you the number of matches. Let us store this in a r variable. Okay, so you need at least r matches to make a and b as equal. But how many matches do we have? How many matches more do you have? This will give you n minus m. So absolute of n minus m. Let us store this in a queue. So you need at least r matches to make Alice and Bob score as equal, and you can have max q matches. You can have q matches. So the second condition is going to be if absolute of r minus q, if this is going to be an even number, then only your answer is going to be an yes, or else your answer is going to be a no. Why? Just now we have seen, then there is going to be a last match. You don't know whom you are going to make win. If there is odd number of matches, then the answer is always going to be a no, because they are never going to be an equal score. Okay, so with that being said, let us code it up. Okay, so let us write the code for this. So first you will be having the test cases. So let us take the test cases, and after that you will be given two values, n and m, where n is nothing but number of matches, m is nothing but number of matches has been played out of n matches, and then you will be given a string s. Now what will I do? I will maintain two variables, Alice1 and Bob1, just to track how many matches how many matches have won by Alice and Bob. So I will simply run a for loop in the string. If it is equal to 1, then Alice has won the ith game, or else Bob has won the ith game. Now remaining, I will store the remaining matches in a variable. So how do we get the remaining matches? N minus m. And to make the Alice score and Bob score as equal, I need to know what is the current difference. So I can know that using Alice1 minus Bob1. So since we don't know which one is larger and which one is smaller, we are going to use a absolute. Okay, So if the remaining matches are less than difference, so to make Alice score equal to Bob's score, I need 10 matches, but the remaining matches are only 5 matches. So I can't make them equal in 5 matches, right? So in this case, the answer is always going to be a no. What about the next one? If the absolute of remaining matches minus this difference modulo 2, this is, if this is equal to 0, then my answer is always going to be an yes. Okay, you are able to make Alice score and Bob score as equal, but right after you making Alice score and Bob score as equal, you are left with few more matches. Those matches should be an even number. If they are odd, then you cannot make both the scores as equal, else your answer is always going to be a no. This should work. And the constraints are also very small. Yeah. So let us jump into the next problem. Yeah guys, so let us see the next problem. So the problem name is minimize sum. So you have an array A of n integers and you have an integer m. Okay, all the n integers will lies within the range from 0 to m minus 1. Okay, so you can do the following operation any number of times, and the operation is you have to simply increment each value by 1, and then you have to do simply modulo m. And you cannot do this for only one element. Let's say you have a few elements, I will do only plus 1 to this and module m. No, this will not work. You have to simply increment all the array values by one position, by one value, and then you have to do modulo m for all the indices. Okay, so find the minimum possible sum array that you can get after doing the above operation some number of times. It can be any number of times. Okay, so this is the input format and this is the output format. You can take a look at this. You can take a look at this. So let us see the constraints here. So the constraint says t is 10 to the power of 4. Okay, this my bad. T is 10 to the power of 4 and n comma m is less than or equal to 10 to the power of 5, and ai is always going to be max to 10 to the power of 5, right? So the sum of n and m both does not exceed 2 into 10 to the power of 5. So n plus m combined, it is not going to exceed 10 to the power of 5 for the overall test cases. Okay, so here which type of time complexity will work? Will n square works here? I don't think so, because if you take n square, even if you take n value as 10 cube, even if you take n value as 10 cube, 10 cube into 10 cube will give you 10 to the power of 6. This is your n square solution, and you will apply test cases. For each test case, it can go till 10 to the power of 4, right? So here itself it is going 10 to the power of 10. So you cannot have more than 10 to the power of 8 instructions per second for a safe side, right? So here big O of n squared solution will not work. The only solution that we should be able to come up with big O of n. Okay, we should be able to come up with only big O of n. So the let us see the sample test cases first. Okay, so there are three test cases in the sample test case. The first one is you are given the size, and then you are given n value. This is m value, this is n value. This m value is nothing but mod value. Okay, mod value, and the below are the array elements 2 0 1. Okay, let us see what is the answer for this. What is the answer for this? So the answer for this is going to be 3 itself. How? So without changing, without performing any operation, what is the total sum that you can get? The total sum that you can get is 3. So can you get some other value which is less than 3? Let us see. What did he mention? You can perform any operation. You have to simply increment all values by 1, and then you have to simply do modulo 3, right? So if I do here 3 modulo 3 will become 0. This 0 will become 1. This 1 will become 2. So what is 0 plus 1 plus 2? Again 3. Now let us try to do it one more time. So this will become 1, this will become 2, this will become 3. So again 3 modulo 3, this is going to be a 0. 1, 2 plus 0, again this is going to be a 3. So no matter what, so no matter how many operations you try, the answer is always going to be a 3. for the first test case. Now let us see the second test case. Okay, there are two elements. So there are two elements, and the mod value is 1000. And what are the elements? The elements are 1 and 1. So here what you can do is you can simply perform an operation of incrementing both the values by 999 times. So when you keep on incrementing the values, at some point this will become 1000, at some point this will become 1000. So what is 1000 plus 1000? Sorry, what is 1000 modulo 1000? It is going to be 0. Here also it is going to be 0. So in total the answer is going to be a 0. So this is the answer for the second test case. Now let us see the third test case. So for 10, there are 4 elements, and the k value is 10, 2917, 2917. So what is the answer for this? What is the answer for this? Let us see. So without performing any operation, what is the total sum till now? 10, 17, 19. 19 is the answer. Can you arrange the sum to less than 19? Let us see. Let us perform the incrementing operation one time. This will become 3. This will become 10, but 10 modulo 10 is going to be a 0. This will become 2. This will become 8. So what is 8 plus 2 plus 3? 8, 9, 10, 10, 11, 12, 13. So 13 is better than 19, right? 13 is better than 19. Let us try a few more operations. 3, this will become 4, this will become 1, this will become 3, this will become 9. This is obviously not better because bigger values. Let us try one more time. 5, 2, 4, this is going to be 0. So let us see this. 5 plus 4 is 9, 9 plus 2 is 11, right? So we got 11 here. Okay, so 11 is better than 13. 11 is better than 13. So I think our answer for this test case is going to be a 11. Okay, so this is the entire problem statement. All you have to do at every operation is increment all the array elements by one value, and after incrementing you have to do modulo m. Okay, and at every operation, when you do this after performing this operation, you have to simply find the sum, and you have to find that sum which is giving you the minimum sum. So in this case 10, 19, 11, 11 is giving us the minimum sum, so you need to simply return 11 as your answer. So this is the problem statement. So try to think of an approach for this. Okay, so let us see the solution. I have taken one sample test cases for better understanding. So if you see the test cases, what is the answer for this? The answer is always going to be a 0, because every element is 4 and you keep on incrementing it, and all the elements will reach 10 at one point, and 10 modulo 10 is always going to be a 0. So the entire sum of the entire array at some operation is going to be a 0, right? So this is the answer for this. Now let us see. What I am saying is you simply take an array of size m. Okay, you simply take an array of size m, 0, 1, 2, 3, 4, 7, 8, 9, 9. So initially all the values in this array is going to be a 0. Initially all the values in this array are going to be a 0. Okay, so what I'm saying is you simply going to find something like this: m minus array of I, m minus array of I. So this will give you the remaining, or we call it as reach. Okay, so here m is nothing but 10, and array of I is going to be a 4. So what do you get? 10 minus 4 is nothing but 6. So you are going to simply increment this value at which is at index 6. You are going to simply increment the value, and this is happened only for one element, but second element, third element, fourth element, all of them are same, right? So this one is going to be 3, 4. So this one is going to be 4. Okay, so at index 6 you will simply have a value which is 4. Okay, now let us see what I am trying to say. So first, basic approach, the brute force approach, what you can do is you will simply run a for loop. Okay, starting from 1 you will go till m. At every operation you will simply increment each element each element in the array by one position, and then you will simply do each element as every element modulo m. You will perform this is using another for loop, and after this you will simply find the sum of the array, and once you find the sum of the array you will simply update this in your answer. Okay, is the sum of the array is smaller than the answer that I am having? Okay, you can do this, but this will give you n square time complexity, which will give you time limit exceed at the end of the day. Okay, so what we can observe is what we can do is we will maintain this array. Okay, we will maintain this array. So you will simply populate this array by using this. You will go to every element, yeah, and you will get this remaining value, which is m minus array of I. This will give you an index within the range from 0 to m minus 1. You will simply increment that index. Okay, so think of it like this. Let me move this. So what I'm saying is, what is your current sum? What is your best answer right now without performing any operation? The best answer is going to be sum of all the array elements and without performing any operation. So in this case, 4 plus 4 is 8, 8 plus 8 is 16. So the best answer is 18, right? So the best answer is 18 till now without performing any operation. So what I am saying is, you will simply start iterating from this one index. Okay, when you are iterating from I equal to 1, simply increment all of these values by 1. Okay, 4 will become 5, this 4 will become 5, this 4 will become 5, this 4 will become 5. Okay, so what is the total sum now? What is the total sum? The sum is 20, but what is the best already having answer that we have? Already we have 16. 16 is better than 20. So is should I assign 20 to 16? No, right? Because 16 is better than 20, so I won't assign. I won't change my sum value. Okay, or let us have an answer as 16. Okay, so right now my sum is 20, so I already have an answer of 16, but right now answer is 20, so I won't assign 20 to answer because I already have a better answer. Okay, go to the next index. Okay, and before going to the next index, are there any values which turned to 0? No, right? There are no values which are turned to 0. Why? Because here the value is 0. So what is this 0 is indicating? You will get to know by the time we reach here. Okay, so I will increment my I pointer again, increment this value by 1. So what do you get? 24, right? You will get 24. Is 24 less than 16? No, so I won't update. I will move to the next index. So again, this will become 7 7 7 7. Now what is the total value? 28, I guess, right? 28. Is 28 less than 16? No. Go to the next index. This will become 8 8 8 8. The total sum will become 32. Is 32 less than 16? No. I will go to the next index. Now again, 9 9 9 9. So what is this? 9 9 18. 18 plus 18 36. Is 36 less than 16? No. I will go to the next index. Now here I have 10 10 10 10. So here I have 10 10 10 10. Now is this value is a positive value? Is it greater than 0? Yes, it is greater than 0. Now what is this telling us? By the time you reach here, by the time you reach this index, there are 4 elements who will become 0. There are 4 elements who will become 0. Here if we have something like 3, here instead of 6 we have 3, then what is that telling us? By the time you reach this index, there are 3 elements which will be turned to 0, but right now we have 4, which means there are 4 values which will be turned to 0. So what is the sum now? The sum is 0, and is 0 is better than our answer? Yes, then you will simply update your answer with 0. Okay, now I think you have understood what is the meaning of this value. By the time you reach this index, there will be 4 elements, there will be x number of elements which will be turned to 0. That is one observation. Second observation, how are we finding this sum? So we are incrementing at every index, we are incrementing these array values by 1, but do we need to do that? My question is, do we need to do that? No, right? We don't need to do that. Why? Because take this sum, 4 4 4 4. So what is the total sum? The total sum is nothing but 4 4 8 8 8 16. Now in the first operation, we'll increment all the values by one position, therefore the sum will become 5 5 5 5. Now do I need to iterate all the elements to get the sum of this value, which is 20? No, right? So you can simply add something like this. You already have existing sum, so for how many elements, what value you are adding? So there are four elements. I am adding value 1. So what is 16 plus 4? That is nothing but 20. Now again you are adding to this 20. There are four elements which will be incremented by 1. This is nothing but 24. Now again you are adding 4 into 1. This will give you 28, and so on. You don't need to iterate the entire array to get the sum after incrementing. Okay, that is one thing is cleared. But when we encounter this 6, when we encounter this 6, how do we find this sum? When we encounter this 6, how do we find this sum? It is simple. So what is this 4 is telling us? There are four elements which will be turned to 0, right? There are four elements which will be turned to 0. So what is the sum by the time you reach here? What is the array sum by the time you reach that index? The array sum is going to be 40, right? So you will simply do minus how many elements are going to be turned to 0. There are four elements which will be turned to 0, and 0 means what is the m value? You will simply put m value here, and our m value is nothing but 10. So 40 minus 40 is nothing but 0. So this is how you are going to solve this problem using with the help of an array. I think I have made everything clear. You how to update, how to get answer, what to do when you have a positive value here. So without wasting any time, let us try to code it. Okay, so let us write the code for this. First, we need to take the test cases. For each test case, what do we need to do? We need to take two values, n and m, c in n, c in m. Now after this, let us declare an array of size n, and we also need to maintain the sum. So let us have a sum. For loop int I is equal to 0, I less than n, I plus plus, sum plus is equal to array of, sorry, c in array of I, then sum plus is equal to array of I. Now what is the next step? Okay, so first we need to vector int, let us declare an array of size m. Let me call the array name as hit. Hit means by the time you reach here, there will be 10 elements which will be hit by modulo m. Okay, so in this case, what I will do, so what is the expression that we have discussed? So it is going to be m minus array of I. So just for the sake of a range, we will simply do modulo m. Okay, if this remaining is greater than 0, then you are going to do hit of remaining plus plus. Okay, so this step is done. Now what is the next step? Long int answer. Initially our answer is going to be sum without performing any operation, and along with it I will maintain one current answer as sum. Now we are going to perform this operation k times. Okay, sorry, m times. Okay, so all elements will increase by one value. So how do we get to know that? Current answer plus equal to n, as simple as that. Okay, now what is the next one? At this hit, I mean, you need to write something like this. If hit of k is greater than 0, then there are few elements which will be turned to 0, which will be toggled to 0, right? So what are those elements? So you can simply do current answer equal to current answer minus, this might be huge, so minus 1 long into m into hit of k. Okay, and then answer is going to be a minimum of answer comma current answer, as simple as that. Now next one is going to be cout answer. Let me run the code. Sample test case is working. Yeah, it got worked. Okay, so that's all for today's video, guys. Thank you for watching the video, and if you have liked the video, please do subscribe and share. And if you want to study DSA in much detail, there is a smart code course by Smart Interviews. Please enroll into our course. And once again, thank you for watching the video.